Welcome to Repeated Factors Part 2. So in the last problem, you'll recall that in the last video, we set up the partial fraction decomposition and we used the repeated factor formula, right? We had x minus 2 squared. It was a repeated factor, so we wrote it once to the first power and a second time to the second power. And we realized that even though that method was kind of not intuitive, it actually does work, okay? So right now what I want to do is pretend I did not know what I was doing, and let's pretend I did not understand repeated factors, right? So let's pretend I thought that if I saw this denominator, I would not know what to do, and I would write a over x minus 1 and b over x minus 2 squared. So like a lot of your questions were, why can't I do this, right? This makes more logical sense to me. I want to sort of prove why you can't do this. All right, so let's pretend we set it up this way and we thought we were doing the right thing. Well, I'm gonna, add the fractions together and solve for a and b just like we normally would. So this would be a times the quantity x minus 2 squared plus b times the quantity x minus 1. Here I would have 6x squared minus 19x plus 15. At this point, I'm not going to deal with the denominators because you know they would be the same. So let's let x equal 2 because we want to solve for b. So I would just be proceeding like normal. If x was 2, the a term would drop out, and 2 minus 1 is 1, so I would have a b equal to, and let's put a 2 in for x. So 6 times 2 squared minus 19 times 2 plus 15. So what's that going to be? So this is going to be 2 squared is 4, 24 minus 38 plus 15. 24 and 15 are 39 minus 38, so b is going to equal 1. Okay, now let's let x equal 1. That will allow me to solve for a. So let x equal 1. Okay, so this is going to make b drop out. 1 minus 2 is negative 1, but negative 1 squared is 1. So 1a is going to equal, and if I plug a 1 here, I'm going to get 6 minus 19 plus 15. And so a is going to equal, that's going to be 2, correct? Okay, so double check that that's right. Yes, I think that's right. All right, so then here's what I would get. I would get that 2 over x minus 1 plus 1 over the quantity x minus 2 squared would be my final answer. And I would be very proud of myself and I would say, oh, look, I solved it, right? But the problem is it wouldn't work. So let's just actually take a second and add these together. Does that equal 6x squared minus 19x plus 15? If you thought no, you're probably right. So I want to just do a quick math demonstration to show you that this is actually not going to work. If I added these together, this would be 2 times the quantity x minus 2 squared plus 1 times x minus 1. This is going to be 2 times, this is going to be x squared minus 4x plus 4, right? If I expanded that binomial, plus x minus 1. Distribute 2x squared minus 8x plus 8 plus x minus 1. Combining all my like terms, I'm going to get 2x squared minus 7x plus 7, which does not make any sense. That's not equal to what I started with. So I'm hoping this illustration indicates why you can't do this, why you actually do need, when you write out the repeated factor, you need that extra term, okay? This is kind of the simplest way that I can explain it to you without doing like a more fancy proof. So just in general, I would like you to give you some, tips for how to handle repeated factors. Okay, so I'm not gonna work these out, but I'm just gonna sort of write down some examples for you. Okay, so what if we had the following, right? We had 3x minus 5 over the quantity, and I'm just making up examples. okay? How would I decompose? Well, I would know that in the denominator, I technically have 3 factors, right? This is really like x plus 1 times x plus 2 times x plus 2. Anytime I have 1, 2, 3 factors, I need 3 fractions. So I'd have a over the quantity x plus 1, but the repeated factor, remember, I'd have to do b over the quantity x plus 2 to the first power, okay, plus c over the quantity x plus 2 to the second power, okay? And you could work this out on your own if you'd like and realize that it would work. Just to generalize this concept a little more, I'll give you a more complicated example. And again, I wouldn't ask you to do anything like this on a test, but just to give you some other examples. What if I had, I'm just gonna, again, make something up, 2x plus 1 over x plus 1 times x plus 4 to the 5th power. So like, what would that look like? Well, here, again, and again, I won't give you this on a test or quiz, but you would have, there would actually be 6 factors in the denominator, right? This would occur 5 times plus this one. So I would need actually 6 fractions. So I'd have to say a over x plus 1 plus b over, and I'd have to write this as x plus 4 to the first power, x plus 4 to the second power, x plus 4 to the third power, x plus 4 to the fourth power, okay? And finally, I would need to say x plus 4 to the 5th power to ensure that I had 6 fractions to account for my 6 factors in the denominator. So I hope that provided a little clarity on repeated factors. Do not hesitate to contact me with any more questions that you have.